So here we're going to create some classes. Well, yeah, we're going to create an enum. So we're going to create a public enum. We'll just name the state, and we'll name this none, up, down, left, right. And public state is equal to state dot none, just to start out. Now we need some stuff. We need speed, so float speed. And we're going to leave speed open in the inspector. We also need a start position. So start position is equal to transform dot position. That's important. So what we're going to do first off is create an if statement. So if, I'm going to grab this, add that in. So if our state is equal to state up, down, what are we going to do? Well, the first thing is we have to use something that's going to help dictate our movement. And what we're going to do is transform dot position is equal to a math f ping pong. And what we're going to do is we're going to its transform position is going to be equal to, we're going to use our start position to start off with. Now if I forget what goes into this, there's this beautiful thing. I go to window, we can go to help, Unity API reference while I have this selected, and it should search for that particular topic. And it did not yield any. So let's just do this. Math ping pong. So we see here there's a vector 3, and then we have here, then we have here our math, our time, and then our position. I always forget to create a new vector 3 with it. So vector 3, and we're going to do math f for our exposition dot ping pong, and we're going to use time dot time times speed, and then we're going to use our start position dot x, and then we're going to use for our current position along y, we'll use our start position dot y, and then start position dot z. And let's check it to make sure I don't have any errors. We're going to build it. Alright, so we have this here. Our script is on it. This is set to none by default. And this should be, what is it? Up, down. And there we go. Well, one ping pong, the way that it calculates, it starts out at 0, and then it moves back and forth kind of in a pattern, like I guess like a sine wave from positive to negative 0, wherever value you dictate. What I also like to do is this. That's why I love using kind of this start position, is because I will also use this in conjunction with this. So I will sometimes I'll put in, well, actually not sometimes, I will. I don't know, I'm acting like, oh, when I'm actually will do this. Start position plus this, and using the start position, which gives me just a little bit more flexibility in this position, so that it's not going to 0 from my start position. It's using that start position as that, and then moving along those bounds. Of course, this is supposed to be up down, so I need to switch this up, and this needs to be left right. Now, let's take this and use this for up down. And I am going to copy this. I'm going to change this to Y. And it's the same thing that we did up here. Left, right. Up, down has some issues. And let's make sure we got everything. And it could be just because, well, there is no floor. From here, it's just they're very small values.
So can you set somehow publicly?
An offset, yeah. So we'll create a public offset. Actually, we'll do it both. Offset X. Oops. And then now for this, we can add to that value if we need to. But forever, how high that it goes, remember in this case it's going to go, well, it's relative, never mind. If I didn't have this as my plus this, that means this position will go all the way to its negative. But in this case, this will be the lowest that it goes. Or left and right, same thing with the other one. Alright, so we have an issue here. Yes?
If you were to set that elevator speed to something really high and you jump the ball onto it, would the ball would basically fly the ball up?
Well, let's see. Alright, here we go. So what? So the ball, yeah, I don't think so either. Let's keep it at 10. We're not really getting any physics from this, and the reason, if this had a rigid body on it, then we would get some from it, but it doesn't. But we do have a problem that we have to address, and that is the ball is never parented. Is never parented to or stays with the platform. Alright, here we go. Let's try this. It never stays with it. That's a problem. So this is how we're going to deal with it. So what we're going to do is, we need to create void on trigger enter 2D collider other. So if other dot tag is equal to player, then what we're going to do is simply make its transform equal to our own. So other dot transform parent is equal to transform. And then what we're going to do is we're going to turn this into on trigger exit 2D. And then once again, if the player leaves this, we're going to set this to null, which means it's no longer parented to, it's now a child of the world and no longer a child of the platform. Now, you still will be able to move. You won't be able to jump because we haven't set that part up yet. But now we stay with it. If you look here under new sprite, there's the player. If I just happen to move, it's no longer a child of it. Now, let's set up our jumps. Well, being able to do this. So what we're going to do is just add another piece to this. So it's other tag.ground, or if our other tag is platform, is grounded as true. And then we'll do the same thing with other tag.ground or other tags.platform is false. And that's how we handle that. And let's go ahead and name this platform. It is not. Now it is. And we'll test. And we can still jump. Alright. And I'm going to go to player movement. I'm going to bring down this some, maybe about 300, and let's do one other thing. So we got our start position here, and what I'm going to do, and this will be the last thing for kind of go on break. So if transform.position.y is less than or equal to, and I got to figure out what's the lowest this can go before I die. So if you build your level and you have things that go down, and then let's say your last platform is like negative something, and this value exceeds that, you're going to kill your player. So keep that in mind. But let's say, and I'm going to use this here, I'm going to go ahead and just say negative 100, which means probably fall for a little bit before that happens. And kind of, right now I'm at 0, and in the world space along Y and Z. So let's say it's less than or equal to negative 100. Same thing with the last game, the rollerball game. Start position is going to be equal to, transform dot position is equal to start position. And you know what? Let's add in one other little thing. Let's say I'm going to create another sprite. We're going to name this checkpoint. I'm going to tag it as checkpoint. And let's get that. Let's move it up. Turn that blue. And component, what we need to do is make sure that this is along Z. That's going to be important. It can move up a little bit. That's not going to be too bad. We can't have it here, so it's got to sit on top of that. And what we're going to do is add in we'll add in a box collider. Turn that is trigger. And what we're going to do is tag it. And we're going to do two things. We got start position, vector 3. Let's name this, let's create one more game. Start position. And we're going to do the same thing. So game start is going to be equal to our transform.position. We want to use that to hold that value. And then what I'm going to do is this. Oops. Alright, so other tag dot checkpoint. What we're going to do is tell start position to be equal to our checkpoint position. Start position is equal to other transform dot position. And let me make sure. Yes, checkpoint with a capital P. Now, its transform position is actually here, centered here. So if I have this in between here, my player will go back to this position once we hit a checkpoint and we die, then that's a problem. So keep that in mind. But let's test it. Let's kill the player. Oh no. Player's dying. It's going to fall. It's going to take a while. And we're there. What I do need to do is this one last thing, because our mass is increasing, our speed is increasing, so we need to turn off our rigid bodies once that happens. So we'll do this rigid body, and we're going to use sleep. There we go. And then we're also going to add this into our, no, we'll just do it there. We don't need to add it anywhere else. And we fall, we fall, we fall. There we go. We're grounded. We hit this, we go from there. Let's say I messed up. Oh no. We go back to our checkpoint position. And your problem, well, what if you have multiple checkpoint positions? Well, let's do that very quickly. So we go here. We go back to that one. And we're set. And then let's say we hit this one. Because it's just straightforward. We're not holding an array of positions. We're just going back to whatever the last checkpoint is. So, very simple system to do that. Alright. Go ahead and take a break when we come back. I'm not going to go over any more code today, so you'll have some time in class to work.